In the space of science and immense secrets, the subject of what existed before the colossal blast has sparked mixed discussions and intrigued characters for a long time. This colossal demand doesn't simply test how we could translate the universe. It challenges the authentic, uttermost constraints of human knowledge. Envision standing at the edge of existence, exploring the titanic shadowing, and pondering what lay there before our universe was conceived. The event of the Big Bang marked the dawn of history, space, and all that we know. But was there a moment beforehand? Could there have been a state of nothingness, a quiet before the vast gathering began? And if this is true, was it a void? Or perhaps there was something far more disturbing that existed before time itself? As we delve deeper into this question, science takes us on a journey beyond the universe's starting point into contemplations that challenge our awareness. Physicist Brian Cox, known for his exploration into the marvels of the universe, proposes that something astonishing could have existed before the Big Bang. He challenges us to rethink our understanding of reality and existence. In this exploration, we'll examine the science, the theories, and the startling secrets that may reveal what existed before everything. We'll explore concepts like grand unification, quantum fluctuations, dark energy, and even multiverses. The answers we uncover may astonish you, but they could also open new understandings of our place in the universe. Prepare to dive deep into a realm beyond imagination and science, where the darkness still weaves shadows, leaving scientists awestruck and sometimes even unsettled. Let us explore what existed before the Big Bang and why these theories challenge everything we thought we knew. To appreciate what might have existed before the Big Bang, we must first carefully examine what the Big Bang truly was. The Big Bang, as scientists define it, refers to the moment when the universe became extremely hot and dense, expanding rapidly to trigger the development of all matter, energy, and the fundamental forces. When we look toward the night sky, we see evidence of this hot beginning, with galaxies spreading out from an early stage. But why did this occur? Was there a time before this dense, hot beginning? According to the theory of cosmic inflation, there was indeed a before, and it was far from empty or silent. Cosmic inflation suggests that before the Big Bang, the universe existed in a state that was cold, empty, and free, essentially like an enormous vacuum. However, this vacuum wasn't entirely empty. It contained a tremendous amount of energy that fueled the rapid expansion of space itself. This expansion, called inflation, happened so quickly that it essentially laid the foundation for everything that followed. Space stretched at unimaginable rates until inflation slowed down, and the energy transformed into matter particles and the forces we see as the Big Bang. But what was the nature of this energy? Why did it suddenly become the universe, and why did it stop? Experts believe that this boundless expansion created patches of the universe, each experiencing its own Big Bang. Imagine a fabric stretching endlessly, with tiny bubbles forming here and there, each bubble representing a universe, including our own. This idea, called the inflationary multiverse, suggests that there are possibly infinite Big Bangs and an infinite number of universes. Our own is just one of many. This colossal, mind-bending reality challenges our understanding of the very universe itself and leaves us with a question. What else is out there? The idea of nothingness before the Big Bang is speculative, not absolute. Even if you strip away all energy, particles, and radiation from the universe, it would still not be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and various forces that create an intricate web of something, even in its most barren form. Regardless of how we imagine stripping away all of these forces, leaving a dead space, the universe would still generate new forms of energy. This fact alone is astonishing to experts, as it suggests that true nothingness may be inconceivable within our boundless perception. Space itself has properties, rules, and constants that prevent it from being absolutely vacant. Imagine creating a region with literally nothing in it. No particles, no radiation, no energy, except quantum fields and fundamental constants. These would still exist, suggesting that this nothingness has properties. For example, there's a phenomenon called zero-point energy, which represents the lowest possible energy state of quantum fields. In this state, particles can still spontaneously appear and disappear, creating a haunting echo of activity even in what should be empty space. This challenges the notion of a true void and suggests that, yes, even before the Big Bang there was something scientists are only beginning to understand. One of the most fascinating theories in modern cosmology is the possibility of eternal inflation. If inflation could create our universe, it's conceivable that it could continue forever. Brian Cox describes an incredibly vast inflationary multiverse, where universes are endlessly created and continue expanding. Imagine each Big Bang as a spark igniting another universe, while inflation continues in different regions, creating countless other universes. This process could theoretically go on forever. This idea of infinite universes gives birth to an intriguing concept of a fractal universe, where each new universe may, in fact, create its own Big Bang. Each universe exists as a separate, independent space, unaffected by others due to the rapid expansion of space. For scientists, this hypothesis is both thrilling and unsettling, as it suggests an endless multiverse with no definitive beginning or end. Imagine our universe being just one tiny piece in a vast, infinite structure, constantly expanding and continually creating new universes. And what if the unsettling truth is that there is no before or after, but rather a timeless pattern of universes forming and decaying? Our understanding of nothingness shifts when we consider quantum field theory. According to this theory, the universe isn't just a collection of matter floating in space. Rather, it's a complex network of energy fields that fill the universe, interacting to create everything we observe. These fields are like invisible oceans, with particles acting as waves or disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they are still active. Particles can appear and vanish in these fields, briefly acquiring energy before returning it. This phenomenon results in virtual particles, entities that temporarily exist and then disappear, leaving only a faint memory of their presence. The concept of virtual particles challenges the idea of a true void. Imagine an empty universe where all matter, radiation, and energy are removed. Would you have total nothingness? According to quantum field theory, you wouldn't. Even in a vacuum, fields would stay dynamic here and there, making transient particles. This steady development in the thing ought not to be anything that suggests the universe doesn't perceive our idea of void. The fields and forces get through, filling the universe with a mysterious energy that prevents absolute nothingness. This grasping raises a fascinating question. Assuming fields make particles and particles make matter, could the universe itself have risen out of this nothingness loaded with quantum fields? Dark energy is a baffling force that presently drives the accelerated expansion of our universe. However, did dark energy exist before the Big Bang? From certain points of view, the fact that dark energy exists today is an artifact of an energy field from before our universe's evolution. The properties of dark energy seem to suggest an epic hidden force that could have existed in some form before the Big Bang. Some theories suggest that dark energy, in a much stronger state, might have powered the inflationary stage, causing rapid expansion. The presence of dark energy suggests that, even if our universe were depleted of all matter and radiation, this force would continue to expand the fabric of spacetime. This idea prompts a disturbing question. If dark energy was present before the Big Bang, could it have formed the conditions that led to the birth of our universe? Could dark energy be the silent architect of inflation, or even the true beginning of our universe? As we explore this possibility, we face the potential of dark energy not just as a force shaping our universe but as a key that could unlock the mysteries of the multiverse itself. Another theory that offers an alternative to the Big Bang as the ultimate beginning is cyclic cosmology. This theory suggests that the universe goes through vast cycles of birth, death, and rebirth. In this model, the Big Bang is not a one-time event but part of an eternal rhythm where universes expand, collapse, and then regenerate in a new cycle. This theory proposes that our universe could have been reborn from the remnants of a previous universe. The process of contraction and expansion in a cyclic pattern would mean there was never a true beginning but rather an everlasting series of universes emerging, evolving, and renewing themselves repeatedly. Cyclic cosmology raises significant questions about time, as it proposes that time itself might be cyclical rather than linear. If this theory is correct, it could imply that what existed before the Big Bang was just another version of the universe, one that collapsed solely to give birth to our current universe. For researchers, this theory offers a rich answer to the question of ultimate origins, suggesting there is no true beginning. The universe has always existed in some form, transcending our notions of time and existence. Early-stage gravitational waves are another fascinating concept that could hold clues to what existed before the Big Bang. Gravitational waves are ripples in spacetime caused by massive cosmic events, and scientists believe primordial waves, if ever detected, could reveal insights into the universe's earliest moments. These waves could serve as echoes of what came before the Big Bang. If detected, they could provide evidence of the universe's past states. The potential discovery of early-stage gravitational waves would be a groundbreaking breakthrough in our understanding of cosmology and might unlock answers to what preceded the Big Bang. Thus, the mystery of what existed before the Big Bang is one of the most profound riddles in science. From the inflationary multiverse to dark energy and cyclic cosmology, the theories are as varied as they are mind-boggling. However, they all point to one tantalizing possibility: that our universe, and perhaps countless others, could have always been part of an eternal cosmic cycle or a vast multiverse. While the answers may elude us for now, they continue to challenge our understanding of time, existence, and reality itself, leaving us forever searching for what lies beyond the universe's birth. To further explore the mysteries of what might have existed before the Big Bang, we need to consider some of the more radical theories that challenge our conventional understanding of physics and spacetime. One such theory involves the concept of quantum gravity, which aims to reconcile quantum mechanics and general relativity. Both theories are incredibly successful in their respective domains, but they are fundamentally incompatible. Quantum mechanics excels in explaining the behavior of small particles at minute scales, while general relativity governs the behavior of large-scale structures like galaxies and black holes. The search for a theory of quantum gravity could hold the key to understanding what happened before the Big Bang, as it could explain how space and time themselves behave at the smallest scales. One of the most promising possibilities for a quantum theory of gravity is loop quantum gravity, LQG. In LQG, the fabric of spacetime is not a smooth, continuous substance as general relativity suggests, but is instead made up of discrete chunks or loops at the smallest scale, called the Planck scale. According to this theory, spacetime could have a granular structure, and time itself might not have existed in the traditional sense before the Big Bang. If this theory is correct, the concept of before the Big Bang might be meaningless. Instead of time stretching back infinitely, there could have been a pre-Big Bang phase in which the classical notion of time breaks down entirely. This would make the question of what preceded the Big Bang fundamentally unanswerable within the framework of our current understanding. Another fascinating theory to consider is the holographic principle, which suggests that the entire universe, as we experience it, might be a sort of 3D hologram. The true nature of reality could be encoded on a lower dimensional surface, much like how a two-dimensional hologram can create the illusion of a three-dimensional object. According to the holographic principle, all the information that describes our universe could, in theory, exist on the boundary of spacetime. In this view, the Big Bang might not be the beginning of the physical universe but the event when the information on the boundary of the universe became real, creating the spacetime we observe. If this theory holds, it could suggest that the concept of before the Big Bang does not exist, as the universe's boundaries and structure might be part of a larger, more complex reality. Another possibility involves the idea of eternal inflation. Eternal inflation is an extension of the inflationary Big Bang model, suggesting that our universe is part of a continuous process of inflationary bubbles. Each bubble could represent a separate, independent universe, while the space between them continues to expand. In this model, there is no definitive beginning to the universe. Instead, it suggests a universe that is endlessly generating new regions, with each new region experiencing its own Big Bang, effectively creating an infinite number of universes. This idea echoes the multiverse theory but is more grounded in the physics of inflationary cosmology.